Hi, Assalamualaikum and good day everyone. I'm Falah Akmal bin Ismail from University Malaysia Perlis UNIMAP. Will present regarding my review paper entitled Application of Deep Learning in Building Digital Twin. As we all know, buildings play a crucial role in our daily lives, and as such, substantial efforts has been directed towards enhancing them. One approach of this improvement is by incorporating digital innovation into the building's entire life cycle, which encompasses stages such as planning, construction, operation, renovation, and also demolition. 3D models have been demonstrated to be effective for facilitating decision making, scenario simulation, and 3D data analysis throughout the life cycle. The creation of digital representation of buildings can be a time-intensive process depending on the desired level of detail (LOD) and extent of the desired representation. Accurate and interconnect 3D data offers the possibility for in-depth analysis, including the improved calculation of areas, facility management, urban planning, and also energy simulation. To make this easier for user, digital twin technology is being introduced. The concept of digital twin involves the establishment of a virtual representation of a tangible object with the purpose of streamlining, optimizing, and preserving the associated physical process. The origin of the digital twin idea was first introduced in 2002 by Michael Greaves, with the concept model consists of three main parts: the physical product, the virtual product, and the connection between the physical and virtual products. Greaves further defined digital twin as the integration of three essential elements: a virtual twin, a physical counterpart such as product system, model, or entity such as robot, car, power turbine, human, hospital, and so on, and a data flow cycle that facilitates the exchange of information between the physical and virtual twins. With the expand of the knowledge, digital twin has increasingly obtained the attention of professionals in various applications in engineering. The digital twin technology can be utilized for buildings in various purposes, such as visualization, modeling, simulation, analysis, and also future planning. So this is good, isn't it? In the construction industry, the technology for constant real-time synchronization of models, providing the companies with the ability to constantly monitor progress in a 4D BIM model. We know when there is a maintenance in a company, all the manufacturing progress need to be shut down regarding the safety, and this will affect the output of that day. We think it might not give a effect so much, but we are totally wrong. Imagine if the maintenance took time from the start to find the root cause for something. How come this does not affect for the level productivity of that day? So, with the concept of digital twin, all the aspects can be predicted from the start, and facility management can make a proper planning. Deep learning and building digital twin are closely related technologies that are increasingly being used together to improve the building performance and management. Deep learning algorithm can be used to analyze the large amount of data from sensors, building management system, and also other sources to generate the real-time insight into building performance. This information can be fed into the digital twin model, which can be used to optimize the building operation, reduce energy consumption, and also improve the building safety. Thus, professionals in a respective field can utilize the results to increase the usage of digital twin, and at the same time realizing the government's intention to create smart technologies in engineering and manufacturing, specifically for existing building, in generating building information modeling BIM. Digital twin technology has been found wide application in various domains, including the predictive maintenance, energy optimization, and also 3D model, building model generation. Right now, I will review on the various deep learnings that are being used in three applications of the building digital twin that I said just now. This review is not meant to be an exhaustive investigation of literature, but a selective representation from the viewpoint. Let us go through for the predictive maintenance. In order to integrate the deep learning with the digital twin for predictive maintenance, I break down the different points and their correlation. First, due to the lack of failure data from industrial companies, deep learning approach in predictive maintenance often rely on unsupervised method. This scarcity has led to the prominence of autoencoders (AE), restricted Boltzmann machine (RBM), and also generative models. But still, right now, many studies already aim to combine different algorithms to create a complex model that leverage the strength of individual techniques. The most common combination for unsupervised predictive maintenance sensor modeling involves convolutional neural network (CNN) and also long short-term memory (LSTM). Networks within the autoencoder or autoencoder-based architecture because it enables effective feature extraction, dimensionally reduction, and anomaly detection, and transfer learning, allowing for accurate prediction and early detection of maintenance issue based on the sensor data. When talk about determining the optimal length of the input segment, it is also a challenge, as short segment may lose valuable information while long segment increase the training time and computational complexity. So, some of researchers combine a nonlinear denoising autoencoder with a GRU network in order to handle length variable signal segments. And also got a researcher modified the bidirectional LSTM by LSTM to incorporate more contextual information and also address the memory limitation. Next, we go for the energy optimization. Recent research studies have focused on popular models like CNN, RNN, and GAN. Deep CNN model have been employed to accurately identify instances of electricity thief that do not follow the periodic patterns. RNN, particularly LSTM, for the time series trend prediction. RNN, especially LSTM networks, have demonstrated exceptional performance in predicting trends in the time series data. LSTM ability is to capture contextual information from both the past and future contributes to accurate prediction. The combination of different models has shown improved usefulness. For example, ANN model can accurately predict the total energy consumption (TEC), life cycle cost (LCC), and life cycle assessment (LCA) for building renovation scenarios. The combination of CNN and LSTM model outperforms other machine learning methods in predicting the residential energy consumption and also reducing the noise in the power consumption data. Researchers have employed the Gray Wolf optimizer, which is we call as GWO, as a meta-heuristic optimization technique to optimize the parameters of deep learning model. This incorporation improve the accuracy and reduce human efforts in parameter selection. So, researchers do the combination of GWO, CNN, and also by LSTM models, which offers the high prediction accuracy, consistent performance, and generalization as ability. It aids in effective utilization of building resources, cost saving, optimal generation unit management, and facilitates the development of net zero buildings. Finally, we go for the last application of digital twin that will be discussed in this paper, which is 3D building model. CNN, GANN, and AE are commonly used deep learning models for learning patterns and features from large amount of data, leading to accurate building model. CNN-based framework have been utilized to detect, localize, and estimate building height in aerial image, enabling the level of detail allowed to building reconstruction. CNN can also perform the semantic segmentation of wire structure, overcoming challenge in generating the 3D reconstruction of complex grid structure. Furthermore, CNN aid in classification and segmentation of roofs in aerial imagery, contributing the 3D building reconstruction. Several crucial gaps in the in the utilization of deep learning for the 3D building model digital twin. This includes the absence of scalable and the computationality, the efficient solution to handle the large and complex data, the lack of integration of the information from diverse sources, and the limited capability to address uncertainty and variation in the real world building environment. The development of optimized deep learning algorithm specifically designed for the 3D building model can handle the vast and intricate data associated with them, and the choice of the best model depends on the various factors such as the input data, the problem complexity, computational resources, and also the individual research finding. CNN, GNN, and AE are commonly used models for automatically reconstructing the building models. So that's all from me. Thank you so much. Thank you.